we're going to start with question 1. A large airline operates 2,000 flights per day. The probability that there is a technical problem with a flight is 0.0015. Okay. We're looking at the probability that there are 2 or more flights with technical problems on any given day. So the probability that x is 2 or more becomes greater than or equal to 2. So that's the same as 1 minus the probability that x is less than or equal to 1. Okay, now the 2,000 is our trial size and that's our probability. So we grab our calculator and we go to stats and distribution, binomial distribution, BCD to get the less than or equal to variable. So x is 1, we're doing page 148. So x is 1 because it's less than or equal to 1. The number of trials was 2,000 and the probability was 0.0015. Turn and we get 0.1989. So 0.1989, I think. Yep. And so then we need to go to menu and go 1 minus 0.1989 to get 0.8011. Okay. So that is correct in the back of the book. Now, question 1b. That the airline has technical problems with flights on 2 consecutive days. Now what we have to do is look at one day and then imagine on your probability tree, what do you do with the probabilities along the branches? Multiply. So we're looking at just one day and we've got technical problems. So what's a technical problem? We're looking at the probability that x is greater than or equal to 1, which is 1 minus the probability that x is less than or equal to 0, which is the same as equal to 0. Less than or to equal to 0 is the same as equal to 0. You'll get the same answer on both. So we're going to go 1 minus, grab our calculator. Not recording then. It's very strange. Okay, so we're doing 1b. We've got that. Grab my calculator. Okay, so we go stats, we go distribution, we go binomial, we go, it doesn't actually matter in this case, variable, and x is 1. No, x is 0. And the number of trials was 2,000 and the probability 0.0015. So we've got 0.497. Was that right? 0.0497, yep. And so then we need to do 1 minus that, so you need to go back to menu and run, and so it's 1 minus 0.0497, and so we get 0.9503. 0.9503. And just checking that answer in the book. Yes. No. Done something wrong. Oh, because that's for one day, right? But the question says for 2 consecutive days, so I actually need to go to the power of 2, or rather multiply itself by itself. And then I've got the 9031, which is the answer. So if we can select and go up. So that there is your probability for one day. So that's for one day. So for 2 consecutive days, I go 0.9503 times 0.9503. That times that along the probability tree. And so then we get the correct answer of 0.903. Okay? Cool? Yeah. We're going to go on to question 2. Okay. Question 2. A bank offers customers a choice of either plain or patterned EFTPOS cards and finds that for every 2 plain ones, so 2 plain, there are 3 patterns. Okay? Calculate the probability that out of the next 6 EFTPOS cards issued, fewer than 4 are patterned. So the probability that X is less than 4, how many trials is there? 6. What's the probability? So it says fewer than 4 is patterned. So what's the probability of getting patterned? 3 out of 5. So for every 5 cards, 3 are patterned. Does that make sense? So 3/5 is the probability of getting patterned. Alright? So then we grab our card. Oh, now we have to rewrite this. That's the probability of X being less than or equal to 3. Okay? So we grab our calculator, and N was 6. Whoops. Get back. There we go. So we need to go into stats and into distribution and binomial. We're doing the BCD because it's less than or equal to, and with variable. So X was 3. The number of trials, 6. And the probability, 3/5. Okay, so we've got 0.4557. Okay, and so if we check that, 0.4557 is correct in the back of the book. Okay. Okay, so question 3. As a quality control measure, a random sample of 20 items is taken from a production line after 500 items have been produced. The whole batch was rejected if 10% or more of the samples is defective. Earlier studies showed that the probability that an individual item was defective was 0.05. So that's our probability. Calculate the probability that the whole batch is rejected. So what's our N sample size? 20, a random sample of 20. So N is 20. What's 10% of 20? 2. So we're looking at the probability of x being greater or equal to 2, because it's 10% or more, isn't it? Does that make sense? The whole batch will be rejected if 10% or more of the sample is defective. So we're definitely dealing with the sample, and the sample was size 20. So any more than 2 out of the 20, and it's like no good. So we've got all our information. We just have to change that to 1 minus the probability of x being less than or equal to 1. Okay, so calculator to the ready. Exit. So we have the sample size of 20. Oh, x is less than or equal to 1. Number of trials 20. Probability 0.05. So we've got 0.7358. Just double check I copied that right. 7358. Okay, so then we need to go back into here and do our 1 minus 0.7358, and we get 0.2642. Let's make sure we read the question correctly. So question 3, 0.2642 rounds correctly. That is correct. Okay, question 4 is a bit of a different one. For question 4, I'll do that on the next video because I'll run out of time here. But the hint is that you need to go back into the book to the start of the binomial and use the formula NCX pi to the x 1 minus pi to the power of n minus x, and that's the probability of x equaling to x. But the issue is that x is 0. So the probability of x equals 0 equals NCX. If I go here, options, and across to probability, I've got the NCR button, so I could go 6C0 1 9C0 1 9 C0 1. Anything C0 is actually 1, so that becomes 1. Pi to the power of 0, anything to the power of 0 is 1. And then I've got 1 minus pi to n. So you're actually solving this. I'll do the question on the next thing, but I'm just warning you, that's what you're going to be using, and you're going to be solving. Oh, that's multiplication. That's times. Okay. So basically here, that is 1 and that is 1. So then it becomes, you've got a probability here that you actually know. Oops, didn't work. You've got a probability there that you know, and you can actually solve, because here you end up with only one unknown, which is this. Okay. So I'll do that in the next video.